Hey everyone, hope you are doing well. Today I'm going to teach you the probability of flipping a coin. Yes, you're not mistaken, this is a 2p Great British coin. I appreciate this is of enormous wealth, and I beg of you, please do not be distracted by this, but focus on the mathematics. So today I'm going to talk about the probability of flipping this coin. So if you want to flip the coin like this, you land it here. You want to guess what it is? It is heads. So congratulations, or I'm sorry that you have failed miserably. As you can imagine, if you throw it on the ground, it could land on its side or whatever, but we're just going to say for the purposes of this video, it's 50-50. You could also imagine maybe the wind resistance has an effect on certain patterns. Now, for the purposes of mathematics, you normally make some assumptions, and it's quite a good assumption to say it's probably roughly a 50-50% chance of heads or tails. So let's write that down. So let's do tails first. So is equal to 50%. And heads, hopefully you can see this, over 50%. So heads is equal to 50%, tails is equal to 50%. Now you may have already noticed these add up to 100%. That's because we've taken into account all our outcomes. So we have all our outcomes taken into account. And because we also want to work out, let's say, the probability of 3 tails in a row, it's going to be a lot easier to work out if we convert these to fractions. So if you didn't know, 50% is also equal to a half. This is 50% also. So a half, and they add up to 1. Now, the significance of the 1 is that you have taken into account all the potential outcomes. Because when you take into account the probability of all potential outcomes, you know you've done it correctly because they add up to 1, because all the outcomes are effectively taken into account. So in this case, we have the half, well, they add up to 1. We've got all the outcomes figured. And from here, let's say we wanted to work out the probability of 3 tails in a row. We would just times that probability by itself 3 times. Or if you had multiple different probabilities of different outcomes, and you wanted to see the probability of this one happening, then this one, and then this one, you'd times them together. But in this case, it's a half times a half times a half. So the probability of 3 tails, call it 3t I guess, is equal to a half times a half times, and you guessed it, a half. So that is going to be equal to, you just times these together, so 1 over 8, which I believe is 12.5%, and that is the probability of getting 3 tails in a row. So we can try that if you want. 1 tails. This is this is live. Okay, heads, okay. You see how it can get a lot more difficult when you want to get more and more consecutively. So for example, let's say you want 5 tails in a row, okay? Makes me think of the Sonic character. Tails. Times a half, so long. Okay, times a half. And because I've recorded this already, it's 1 over 32. But all you do is times these. So it's 2 times 2. These are all 1, so they're all times together on top. 2 times 2 is 4, 8, 16, 32. 1 over 32. So as you can see, it's doubling each time because you've got a 2 on the bottom, 1 on the top, so the ones are staying the same. And you can imagine if you want, 7 in a row, or 9 in a row, or 10 in a row, it's going to get more and more ridiculous. And I guess on, would you call it like a meta level, on a larger scale, you can imagine that these probabilities kind of pan out in a big tree almost. So you have the first coin toss, and it's here, and it goes heads or tails. And then that's a 50-50% or 50-50 chance, 1 over 2 chance for each. And then each of them, if you did it again, then that's a 50-50. and then each of them do 50-50. So you can imagine you get this massive sort of tree. I guess you would actually call it a tree diagram, but it doesn't matter. You have this big tree, this big branch of all these probabilities, and then all those outcomes, will be taken into account. It'll take into account all those potential outcomes. So, for example, the probability, and I'm digressing a bit here, but, for example, if you wanted to, this is, I guess, the first sequence of events. If you did it again, I imagine it'd be 25% for each. What if you had a tails and tails, or you have a heads and heads, or you could have a heads tails or tails heads? That's if you spin the coin, what's that, 2 times? This hasn't been rehearsed, so kind of winging this bit a bit. So they would all equal be a half times a half, which is 1/4, so 25%. And these are all like the same number because we're working with a half on both sides, but 25%. And then you can imagine for you would have even more outcomes. If you did it 3 times, I guess it would double each time. But I'm digressing a bit, but hopefully that gives you some, I guess, entry level understanding of probability of flipping a coin. And yeah, hopefully it makes sense. Hopefully it was clear. I appreciate I didn't go too crazy with examples or anything, and you could definitely go a lot deeper into probability, and I guess statistics probably fall under statistics, but hopefully it made sense. Hopefully it was clear. I hope you're not jealous of my coin. And yeah, I appreciate you watching. So thank you for watching, especially if you made it this far. Thanks again, and best of luck with all your maths.